Welcome to all for my presentation. We see about one component system. This presentation was submitted by Kohila from BE first year. We discuss about the important points such as phase, component, phase diagram, degree of freedom, phase rule, phase diagram of one component system. First, what is phase? A phase is defined as any homogeneous, physically distant, and mechanically separable position of a system which is separated from other parts of the system by definite boundaries. Example, consider a water system consists of three spaces: ice, water, and vapor. Each phase is physically distant and homogeneous, and there are definite boundaries between phases. So, this forms three phases. Next, we see about component. A component are defined as the smallest number of independently variable constituents by means of which the composition of each phase can be expressed in the form of chemical equilibrium. Again, also consider a same water system. The chemical composition of all the three phases in H2O but are in different physical form. Hence, the number of component is 1. Next, we see about phase diagram. What is phase diagram? A phase diagram is a graph obtained by plotting one degree of freedom against another. There are some types of phase diagram, that is PT diagram and TC diagram. PT means pressure with temperature. TC means temperature with concentration. Next, degree of freedom, that is denoted as F. Degree of freedom is defined as the minimum number of independent variable factors such as temperature, pressure, and concentration, which must be fixed in order to define a system completely. Again, we take the ice, equilibrium water, equilibrium vapor. These three phases will be in equilibrium only at the particular temperature and pressure. Hence, this system does not have any degree of freedom, so it is a non-variant or zero variant. Next, we discuss about phase rule. This is important for the one component system, the phase rule. Then the number of degree of freedom of the system is related to number of components and number of phase by the following phase rule equation, that is F is equal to C minus P plus 2. This was established by J.W. James in 1874. One component system. A system which consists of different phases of the same chemical species at equilibrium is called an one component system. Some examples of one component systems are H2O, that is water system, CO2 system, and S system. The diagram for the water system is here. I show the diagram for water system. First, I explain. Water exists in three possible phases, namely solid, liquid, and vapor. Hence, there can be three forms of equilibrium, that is solid equilibrium to liquid, liquid equilibrium to vapor, solid equilibrium to vapor. Each of the above equilibrium involves two phases. The phase diagram of water system is here. This phase diagram contains curves. This phase diagram contains curves, areas, and triple point. Curves. First, we see about the curves. Curves have OA curves, OB curves, and OC curves. Here, some curves are shown in the figure. First, we see about curve OA. curve OA. This is curve OA. This is curve OA. We see about curve A. The curve OA is called vaporization curve. It represents the equilibrium between water and vapor. At any point of the curve, the following equilibrium will exist. Water equilibrium to water vapor. The degree of freedom of the system is 1, that is univariant. Thus applying the phase rule equation, F is equal to C minus P plus 2 is equal to C is equal to 1, that is component, phase is equal to 2, that is minus 2 plus 2, minus 2 plus 2 cancel, so F is equal to 1, that is univariant. The equilibrium either line OA will extend up to critical temperature 374 degrees Celsius. Beyond the critical temperature, the equilibrium will disappear, only the water vapor will exist. Next, we see about OB curve. This is OB curve. The OB curve have sublimation curve. So next we see about OB curve. The curve OB is called sublimation curve of ice. It represents the equilibrium between ice and vapor. The degree of freedom of the system is 1, univariant. This is predicted by phase rule. F is equal to C minus P plus 2 is a phase rule equation. So F is equal to, it is component is 1, so is equal to 1. Phase is equal to 2, that is ice and water vapor, plus 2. Minus 2 plus 2 cancel, so F is equal to 1. The equilibrium line OB will extend up to the absolute 0 minus 273 degrees Celsius, where no vapor can be present and only ice will exist. Next we see about OC curve. This to this. The OC curve is called melting curve. Melting point curve of ice. It represents the equilibrium between ice and water. At any point of the curve, will the following equilibrium will exist: ice, equilibrium, water. The degree of freedom of the system is same 1, either univariant. Same substitute, F is equal to C minus P plus 2. F here component is 1, phase is 2. So 1 minus 2 plus 2 is equal to plus 2 minus 2 cancel. So F is equal to 1. So the same degree of freedom is 1. Next, we recall for the curves, because we have 3 curves: curve A, curve B, curve C. First curve name is vapor pressure curve, that is vaporization curve, curve A. Liquid converted into vapor have 1 degree of freedom. Next, second is curve B, that is sublimation curve. Solid convert to vapor have 1 degree of freedom. Next, melting curve, that is curve C. Solid convert to liquid have 1 degree of freedom. Next, I said the phase diagram has areas, curves, triple point. We see about the curves, that is curve A, curve B, curve C. Next we see about the triple point. The triple point implies solid, equilibrium liquid, equilibrium vapor. The 3 boundary lines, that is curve A, curve B, curve C, meet at the point O, where 3 phases, namely solid, liquid and vapor, are simultaneously at equilibrium. The point is called a triple point. At the point, the following equilibrium will exist. There, the degree of freedom is 0, because F is equal to C minus P plus 2. Here, component is 1. So, F is equal to 1. But phase is 3. So, minus 3. 1 plus 2. 1 plus 2, 3. 3 minus 3 is equal to 0. Here the temperature is 0.0075 degrees Celsius and pressure is 4.758 millimeter respectively. That is triple point, where triple point is a meeting of curve A, curve B, curve C. That is triple point, and the phase degree of freedom is 0. That about triple point. Next, the diagram shows another curve. The curve here OB dash, that is metastable equilibrium. OB dash is a metastable equilibrium. Next we see about metastable equilibrium. The curve OB dash is called vapor pressure curve of the supercooled water or metastable equilibrium. That is supercooled water equilibrium to vapor. Sometimes water can be cooled below 0 degree Celsius without the formation of ice. This water is called supercooled water. Supercooled water is unstable and it cannot be converted into solid by seeding or by sliding disturbance. Next we see about areas. Area AOC, BOC, AOB represent water, ice and vapor respectively. In order to define the system, at any point in the areas, it is essential to specify both temperature and pressure. The degree of freedom of the system is 2, that is bivariant. This is protected by the phase rule. Same formula, degree of freedom, F is equal to C minus P plus 2, F is equal to 1 minus 1 because phase is here 1, that is 1 area plus 2. So is equal to 2. Thank you for all and thank you sir for giving this opportunity for me.